Okay, so sorry, I got a phone call and it cut my video, but I mean, you will be fine. Okay, so let's keep it going. So here we have 3 over 1. So what does that simplify? 3. Here we have, remember, it's y over x, just the way you would find slope, right? Rise over run, so y's on top, x at the bottom. So this would be 6 over 2. Well, what's 6 divided by 2? 3. Oh, interesting. So right here, we have, remember, y over x, so 9 over 3. So 9 divided by 3, well, what's 9 divided by 3? 3. Keep going. 15 over 5. 15 divided by 5? 3. 30 divided by 10. Well, what's 30 divided by 10? 3. All of these ordered pairs are directly proportional to each other, right? So that means that they all simplify to the same thing. So 3 over 1 equals 6 over 2. 6 over 2 equals 9 over 3. 9 over 3 equals 15 over 5. And 15 over 5 equals 30 over 10. They are all equivalent to each other. As to where on this side, they were not, right? These two do not equal each other. These two do not equal each other. These proportions are not equal to each other because it clearly has a y-intercept that is not at 0, 0. This one does, so every single one of these has a slope of 3, which we don't call slope when it's direct variation. We call it the constant of variation. So the constant of variation here would be 3. So constant of variation equals 3, which remember it's really just your k. Okay, so your equation here would be y equals 3x. Ta-da, you're done. But you'll see more examples like that in a minute. Okay, now over here, right, because we know it's not directly proportional, you would have to use 2 points the way you're used to using. So there's nothing wrong with that. Okay, so I would use 0, 4. So 0, 4, and then let's use 1, 6. So x1, y1, x2, y2. So we would have 6 minus 4 over 1 minus 0. 6 minus 4 is 2. 1 minus 0 is 1. So you have a slope of 2. 2 divided by 1 is 2. You have a slope of 2, and we have a y-intercept. So slope is 2, and you have a y-intercept at 4, right? So then you would have y equals 2x plus 4. Not directly proportional. It's still a linear function, right? There is a relationship here. But the difference is that it's moved up 4 units, okay? So then you have to use 2 separate points. Okay. Oh my gosh, good question. Okay, so Miss, what if I forget that that's directly proportional? Can I just use the slope formula to figure out my slope and do the same thing? Oh my God, what a great question. Yes, 100%. If you happen to forget that this is directly proportional or it's direct variation, well, guess what? It's still a table. You still know it's linear. Can you do y2 minus y1 over x2 minus x1? Well, yeah, why not? You're still going to get a slope of 3, right? Or a constant of variation. You're still going to get 3, and you still put that in front of the x. So y equals 3x, okay? Good question. Whoever came up with that question. Good job there. Okay. Now, last section before we move on is going to be this part right here, right? So key words, right? So for application. So we already know slope, right? There's rate of change per, every, or each, y-intercept, anything that happens once, there's something you start with. Now, if you see a problem, a word problem, it's going to physically tell you that it's direct variation if it doesn't tell you that, hey, here's this, right? So if you have a y-intercept of 0, 0, it's automatically direct variation, okay? But if they give you just a normal table, I mean, just do it the normal way, like it's fine, okay? But if they specifically tell you any of these keywords, then that means you can set up a proportion. You know that every point on that line is going to be proportional to every other point on that line. Some of those keywords: direct variation, varies directly, Directly varies. Directly proportional. Very directly. Constant of variation. You're going to notice that a lot of these, I mean, how many combinations can I possibly have with the words direct and variation, right? Like, okay, yeah, I get it. So anything that looks like that, it's pretty much telling you it's proportional to every other point on that line because it goes through the origin. Okay, so that's this part right here. All right, so let's go ahead and do some examples. Okay, so example 1. Identify which of the following are direct variation. Okay, so I just realized I forgot to draw these in. Okay, so let's make this one like this. Let's make this one like that. And then, okay, so sorry about that. Okay, so now that we have these, so if you have a graph, right, all you have to look is, does it go through the origin, yes or no? So this, does it go through the origin? Yeah. So what does that mean? It's direct variation, right? Which means we would be using the equation y equals kx. Okay, for B. Now, for this one, you can see that it's close to the origin, right? But it's not. It's a little off. So what does that mean? Well, it probably means that they got their pizzas delivered, right? And you know, if you get delivery, do they charge you a fee? Yeah, which is why it's a little off center, right? So this is not direct variation. So you would have to do y equals mx plus b. So you have to find your y-intercept and you would have to find your slope also. And which means you would have to have 2 individual points. For this first one, because I know it's direct variation, I just need 1 point and I can do y over x. For this one, I would have to do y2 minus y1 over x2 minus x1. This last one, again, you should be able to do this one on your own just based off of a simple fact. 5, 4, 3, 2, 1. Okay. Oh my gosh, good job. You got it right. Yay. It's direct variation. Which means all I need is 1 point and I would just be able to do, right? This is x, y. And to find my constant of variation, I would just do y over x because my other point would be 0, 0, right? We talked about this. So I would use the equation y equals kx. So for D, which one of these, right? Remember, we know it's a linear function. We're still doing linear functions, so that's not a debate here. What we are wondering is it y equals mx plus b or is it y equals kx? Well, which one of these does this one look like, right? Does it have a 0 y-intercept or does it have a y-intercept that is not 0? So right here, you should be able to tell me that it has a y-intercept of 2, which automatically makes it not direct. It's not proportional, right? Because it has a slope of 3 and a y-intercept at 2. In order for this to be direct variation, it would have to have a y-intercept of 0. So E, y equals 1/2 times x. Okay, again, comparing it to y equals k over x. Sorry, I don't know where I got that from. Y equals kx or y equals mx plus b. Which one does it mimic? Well, we can see that there's nothing here, so that means that's plus 0, which means my y-intercept is 0. So this is direct variation. And you're going to have some practice problems on your Nearpod, so make sure you're paying attention because you're going to have to submit your Nearpod so that we can look over it. So our direct variation, so what does that mean? We have a k and my constant of variation is 1/2 and my y-intercept is 0, right? Because, hello, that's what we know. That's what makes it direct variation. F, -2 plus x. Now, notice that we switched the order on you, right? But it does not change the fact that this mimics y equals mx plus b. So our slope would be 1 and our y-intercept would be -2. So this is not direct variation. This is just the normal y equals mx plus b. Okay, example 2. Find the constant of variation. Okay, so what is the constant of variation? Well, let's look at our notes. Okay, constant of variation is right here. And we can see that k equals y over x. Okay, so constant of variation, k equals y over x, right? Of y equals 3 when x equals -2. So they gave me information that I need. Y equals 3 and x equals -2. I know how to find my constant of variation. I just have to put y over x. So k equals, let's rewrite it, y over x. Y is 3, so I'm going to substitute 3 in for y. And then x is -2. So over -2. So my constant of variation is -3 over 2. Ta-da! So you really could go on ahead and write an equation, right? So your equation, it's not asking for it, but this is just so we see it. Y equals your k, which we have, so -3 over 2x. Ta-da! Okay, so this is just side, right? But this is what it was actually asking for. Okay, example 3. The value of y varies directly with x. Write a function that represents the relationship between x and y if y equals 15 over 4 and x equals 20. Okay, so this is going to require some math. All right, so let's read it again. The value of y varies directly. So remember, there's those key words, right? So I know that there is a proportion here, right? So the value of y varies directly with x. Write a function. So when it's telling me to write a function, that really means I want an equation that represents the relationship between x and y if y equals 15 over 4 and x equals 20. Okay, so I want an equation. So my equation is y equals kx, right? And I know that because it says varies directly. And I know how to find k, right? So there's 2 ways you can do this, and I'm going to show you both of them, and you can pick whatever makes you happy. Okay? All right. So here's the first way, right? Method 1. Y equals kx. We have y, 15 over 4, equals k times x, and x is 20, times 20. So if I want to isolate k, all I have to do is divide by 20. So 15 over 4 divided by 20. Oh my Jesus, why did I do this to myself? I need a calculator. Where's my calculator? Okay, sorry about that. I can't use the calculator on my phone because I'm recording with my phone. Okay, so here's our calculator. So we have alpha y equals enter to get a fraction, right? So can we see that? Yeah. So here's our fraction. On the top, you have a fraction. So alpha y equals enter. So we're going to put 15 over 4. Notice that we have a little fraction and then the big fraction, right? Which is what I have, a little fraction and then a big fraction. Then at the bottom, we have 20. Hit enter, 3 over 16. Yeah, I was not trying to do that by hand. So 20 divided by 20 simplifies. So k equals whatever we got here, which was 3 over 16. So that means that my constant of variation is 3 over 16. All I have to do is plug that back in. So y equals 3 over 16x. Ta-da, there's my function. Okay, method 2, which really I don't think you can call it a different method. You're just pretty much taking a shortcut, I guess. We already know how to find the constant of variation. That's y equals y over x. K equals y over x. Again, we have y, which is 15 over 4 over x, which is 20, which you will see that you have the same thing over here, right? So the difference is that we plugged it into the equation and then we saw for k. Here, my k is already isolated, so I'm just plugging it in. You're going to type the exact same thing into the calculator. So then you end up with k equals 3 over 16, which is still y equals 3 over 16x. So there's your function. All right. So whichever one made more sense to you, that's the way you can do it. Go on ahead and rewind and watch that again if you need to. Okay. Example 4. Write an equation, again, equation for a direct variation. There's our beautiful magical words. Oh my Lord. Okay, so write an equation, right? And because it says it's direct variation, I already know that my equation is going to have to be y equals kx with a graph that passes through negative 590. So this time I gave you an ordered pair, but that's okay because every time you see an ordered pair, what are you going to label it? X, Y, right? So again, you can do it whichever method you want, but I already know how to find my constant of variation, right? So I know that I want y equals kx. This is the goal. So I need to find k. And how do we do that? Well, we do k equals y over x. So all we have to do is plug these numbers in and wham, bam, thank you, Sam. There you go. So y is 90 over x, which is negative 5. And then simplify, right? So alpha y equals center, 90 over negative 5, which is negative 18. So my constant of variation here would be negative 18. Now that we have our k, you just plug it back in. So y equals negative 18x. There's my equation, which is what it was asking for. Write an equation. Here it is. Example 5. Y varies directly with x. There you go again with those words. So y varies directly with x, which is important because I see that. I know that I don't have to have another point because my other point would be the origin. So y varies directly with x. If y equals negative 14 when x equals negative 7, find x when y equals 22. Whoa, whoa, whoa. Miss, I thought you said I only needed 1 point or one set of numbers. Why am I seeing 3 numbers? Okay, so let's break it down. Y varies directly with x. Cool, we got that part, yeah. If y equals negative 14, when x equals negative 7, so that word is connecting these two numbers, right? If y equals negative 14, when x is equal to negative 7, so that part right there tells me, right, x is negative 7 and y is negative 14. Comma, find x. So what am I looking for? I'm looking for x. This is what we want. When, here's that word, connecting it to something again, y equals 22. Okay, so let's step back a minute. Remember what we were saying earlier when we were looking at our chart, right? When we have a direct variation type problem, we know that every single point is going to be proportional to each other, right? This point is going to equal that point, which is going to equal the next point, which is going to equal the next point, because they're all proportional, which is what it's saying here. If y equals negative 14 when x is equal to negative 7, find x when y equals 22. So this is telling you you have two things that are equal to each other because it says it varies directly. So we already know how we're supposed to write this, y over x. That is how we find when something is directly proportional, right? Y over x right here. So that's what we have. What was given to us? Negative 14 over negative 7. And I know these go together because of this connecting word when. Now it's telling me to find x. Well, where is x? At the top or the bottom? It's at the bottom. When, there's that connecting word, when y equals 22. So for this x, we know y has to be 22. Okay, we have a proportion. Hopefully you remember how to solve for these just a wee bit from middle school, but if you don't, it's okay. Basically, we're just gonna cross multiply, right? So what does that mean? That means you're gonna cross diagonally and you're gonna multiply. So right here, we're gonna have negative 7 times 22. So negative 7 times 22, right? That's what we have there. And then we're gonna multiply negative 14 times x. So negative 14 times x. So let's simplify. Negative 7 times 22 is negative 154. And that's going to equal negative 14x. So we want to isolate the variable. So we would just divide both sides by negative 14. So negative 154 divided by negative 14 would give us a positive 11. So our x is positive 11 according to this. How could I check my work? Well, remember, if they vary directly, then they have to be proportional, right? So negative 14 over negative 7, is that equal to 22 over what we're saying is our x, which is 11? Well, all we have to do is simplify, right? So negative 14 over negative 7 is a positive 2. Now we're going to do 22 over 11. 22 divided by 11 is a positive 2. So 2 equals 2. Yes, they are directly proportional because we did that with our table right here. Anything that's direct variation, each ordered pair, right? It's constant of variation. It's going to equal the next, which is going to equal the next, which is going to equal the next. So yes, our answer would be x equals 11. Last example, right? Yeah. The mass of a substance varies directly. Oh my God, there's those beautiful words again. Magic, it's magic. With the volume of the substance. Okay, so hold on, let's read that again. The mass of a substance. Okay, so the mass of a substance varies directly with the volume of a substance. So we're directly comparing mass and volume. Okay, wait, hold up. We didn't have that before. What did we have? Y varies directly with x. Direct variation, negative 5 over 90. Okay. What else did we have? Y varies directly with x. Okay. So this is a word problem. This is our application problem, right? This is our real world scenario. So we know that mass varies directly with the volume. The volume of 100 kilograms. Okay, so volume right here, volume of 100 kilograms of the substance is 80 liters. Okay, what is the volume? So this is what we want, right? What, and how do I know that? Because of the word what. What, because I'm about to ask you for something. So what is the volume? This is what we want. In liters of 3.2 kilograms of this substance. So what is the volume? And volume is in liters of 3.2 kilograms of this substance. Okay, so the first thing we need to know is that notice anytime we're talking about direct variation, y comes first, right? So y varies directly with x. So let's write that down. So we have the mass of a substance, which we know mass is in kilograms, right? Over the second, which is volume, which we know is, what is the volume in liters, which is liters. Okay, so we're staying organized. Okay, what is the volume in liters of 3.2 kilograms of this substance? Well, we know that if it varies directly, I can set up a proportion because I'm saying that this is going to be proportional to the other half, right? Which means it's going to simplify down to the same constant of variation. So the volume of 100 kilograms of the substance is 80 liters. Okay, so 100 kg. Where do I see kg? Up here. So I'm going to put 100 kg on the top of the substance. So the volume is 80 liters. So I'm going to put liters is at the bottom. So I'm going to put 80 at the bottom. Right? That was one sentence. The volume of 100 kilograms of the substance is 80 liters. What is the volume? This is what we want in liters. So we're looking for volume. Where's volume? Volume is down here in liters. So we're looking for volume in liters of 3.2 kg. And we see how it says 3.2 kg, our kg's on top. So it makes sense for our 3.2 to be up here. Now that we have our proportion set up, we can cross multiply. So we have 80 times 3.2. So 80 times 3.2. And that's going to equal the other. So 100 times V, right? Because that's what we're looking for. We're looking for the volume. So 80 times 3.2 is 256 equals 100 V. So how do we isolate for this variable? We divide by 100, right? Because we're multiplying there, so divide by 100. So 256 divided by 100 would be 2.56 equals V. So our volume, so the volume is 2.56 liters for 3.2 kilograms of the substance. Now remember, we talked about how we would check our work, right? So off here to the side, just to double check, right? How would we check our work? Because we know it's directly proportional, we know that 100 over 80 has to be the equivalent to 3.2 over 2.56. So let's see. 100 over 80, right? That's 1.25. Now let's do 3.2 over 2.56. And that's equivalent to 1.25. So these two are directly proportional. And we know that because it also stated it in the problem varies directly, which is the reason we can set up a proportion, because that's what it's telling us. So, ta-da, there's your notes. Sorry about the two-part video and about the mini intermission. Is that what that's called? Intermission. All right. Well, now go to your Nearpod, do the practice problems, work through it, do your exit ticket, and study for your test. Bye.